Okay, not every single graph out there, not every single one always has x as the variable, right? You can also find an area, it's just between two curves. So we could also find this area with respect to the y-axis. Cool, right? I'm going to write the definition, but you're going to see it's basically the same. So check this out. Suppose that f and g are continuous functions. With, surprise, surprise, f of y, right? So f of y is the variable that's being used here, is greater than or equal to g of y on the interval from C to D. So it's still from one value to another, but typically when you do y, you use C and D instead of A and B, just to show that it's different. The area of the region bounded by the graphs x is equal to f of y and x is equal to g of y on my interval here from C to D is this. Area is equal to, I'm integrating from C to D of f of y minus g of y dy. Now, I have harped and harped and harped about these differentials, right? Welcome to why that happened. This differential, whatever the differential is, here it is as a y. Your variables have to be in terms of y. Your integral has to be in terms of y. It makes an impact. Just like up here, I have my f of y here is greater than my g of y. When we're looking at this, this is going to be still quote unquote top minus bottom, except this is going to be whatever's on the right and this is going to be on the left because my output is going to be the x value, the greater x value, and the lesser y value or lesser x value when I have that output. All right, because y is the variable. All right, check this out. This is going to be right minus left. Here's a visual of this one because this is different than what we're used to seeing. So I want to make sure you look at this. I'm going to make this bigger down here. When I'm looking at these graphs, I am still going from top minus bottom. If I could, and I don't know how to do that here, then if I'm looking at that, this is my right still, or the top. If you turn your head sideways, right, and you're looking at this, it's still the top minus the bottom. The biggest value and the smallest value. It's that same concept. If you turn this, I wonder if I can. Let's see if we can get fancy here for just a second. Can I do like this? We're so amazing. Okay, so here, if I were to turn this, then that is top minus bottom. Do you see that? Normally, we have our horizontal axis as our x-axis, but it's the same concept, right? It's still the top minus bottom concept that we're looking at, just the same as the other one, except this one is going to be the bigger value and the smaller value. All right. Let me see if I totally messed that up or if I can swing it back around here. Oh, technology is beautiful, you guys. Look at that. Look at that. So if you twist your head sideways, and I know you can't see me doing this, but if you twist your head sideways, just like we did there, then sometimes that's helpful. Here's the moral of the story. I know I'm using dy here. If y is the variable that is in my functions, that's a good tip off I'm using dy, and y is going to be my axis. If my graphs are side by side, right? some value here side by side, and it's easier to go top minus bottom this way than to try to figure out what this is. Now, could I split this up here? Yeah, but this one is function to function, the exact same function, so I can't really even do that. It's not going to do me any good to split this up here. Here, I have to go by the y-axis because I can't go from function to function, right? It has to go from one to another. Different functions. It can't be the same one. All right? Okay.